Hello everyone. Today we are going to solve problems on Demoivre theorem type number 2, where we have to find out expansions of these functions nth power of sin theta, nth power of cos theta, sin n theta, cos n theta and tan n theta. For this, let us assume x is equal to cos theta plus I sin theta. Then 1 upon x becomes cos theta minus I sin theta, and using this, applying De Moivre theorem, x raised to n, that is equal to cos n theta plus I sin n theta, 1 upon x raised to n is equal to cos n theta minus I sin n theta. Then formula for nth power of cos theta, that is formula becomes 1 upon 2 x plus 1 upon x into bracket and its power n. You have to remember this for finding expansion of nth power of cos theta. Similar to this, nth power of sin theta, that will be 1 upon 2i x minus 1 upon x bracket close to the power n. Then cos n theta, which is nothing but real part of expansion of this, cos theta plus I sin theta to the power n. Sin n theta is imaginary part of expansion of this bracket, cos theta plus I sin theta to the power n. Then x raised to n plus 1 upon x raised to n is equal to 2 cos n theta. X to the power n minus 1 upon x to the power n is equal to 2i. X to the power n minus 1 upon x to the power n is 2i sin n theta. So we have to remember this formula and assumption, that is x is equal to cos theta plus I sin theta. Okay, let us solve problems. This is first sum which we are going to solve. Here prove that sixth power of cos theta minus sixth power of sin theta is equal to 1 upon 16 times into bracket cos 6 theta plus 15 times cos 2 theta. Let us prove this. Okay, this is first sum on this type. To prove, let us find cos 6 theta and sin 6 theta separately. Solution for this. We can say step number 1, to find sixth power of cos theta. Sixth power of cos theta can be written as cos theta to the power 6. Cos theta to the power 6. Okay. Then cos theta is nothing but 1 upon 2 into bracket x plus 1 upon x to the power 6. Now we have to expand this x plus 1 upon x to the power 6. So this is equal to 1 upon 2 to the power 6 x plus 1 upon x to the power 6. This is equal to 1 upon 2 to the power 6. 2 to the power 6 is equal to 64. 1 upon 64. Now expand this bracket binomially. We have to use binomial expansion. So x to the power, here in between these two terms there is plus sign and power is also with plus sign. So all terms will be positive. Hence x to the power 6 plus n is 6. So binomial coefficients will be 1, 6, 15, 20, 15, 6, 1. 6 times x to the power 5 into 1 upon x plus 15 times x to the power 4 into 1 upon x square plus 20 times x cube into 1 upon x cube and then plus 15 times x square into 1 upon x to the power 4 plus 6 times x into 1 upon x to the power 5 plus 1 upon x to the power 6. Okay, now we have to simplify this. Let us simplify this. This is equal to 1 upon 64 x to the power 6 plus 6 times x to the power 4 plus 15 times x square plus 20 plus 15 times 1 upon x square plus 6 times 1 upon x to the power 4 plus 1 upon x to the power 6. Now we have to collect first term and last term, then second term and second last term, third term and third last term. This term remains as it is. So this is equal to 1 upon 64 into bracket x to the power 6 plus 1 upon x to the power 6 plus taking 6 common x raised to 4 plus 1 upon x raised to 4. Okay, then plus 15 times into bracket x square plus 1 upon x square plus 20. And now you know x to the power n plus 1 upon x to the power n, that is equal to 2 cos n theta. Applying that formula, since x to the power n plus 1 upon x to the power n, this is equal to 2 cos n theta. You know this formula. So applying this formula, this can be written as, this is equal to 1 upon 64 into bracket, this becomes 2 cos 6 theta plus 6 into, for this bracket, 2 cos 4 theta plus 15 times 2 cos 2 theta plus 20. Okay, now you can take 2 common from this square bracket, then this is equal to, we can write, this is equal to 1 upon 32 cos 6 theta plus 6 times cos 4 theta plus 15 times cos 2 theta plus 10. Okay, this is 6th power of cos theta. Let us find, in step number 2, we have to find out 6th power of sin theta. Similar to this. Okay, let us find 6th power of sin theta. Step 2. Sixth power of sin theta is equal to sin theta to the power 6, and which is equal to, sin theta is nothing but 1 upon 2i x minus 1 upon x. Okay, where x is cos theta plus I sin theta, its power 6. Expansion will be same like previous. sixth power of cos theta. So sixth power of sin theta, we can write this is equal to 1 upon 2 to the power 6 into I to the power 6 into bracket x minus 1 upon x to the power 6. Now try to understand, there is minus sign between these two terms and power is with plus sign. So expansion contains alternate plus minus signs. Means first term positive, second term negative, third term positive, fourth term negative, like that. Okay. So this is equal to 1 upon 2 to the power 6, that is 64, into I to the power 6 means I square, and I square is what? Minus 1. Minus 1. Now expansion of this. Similar to previous sum, alternate with alternate plus minus signs. You can see here expansion like this, x raised to 6 plus 6x raised to 4. But here all terms are positive, and now here we want alternate plus minus signs. So we can write like this, x to the power 6 minus 6 times x raised to 4 plus 15 times x square minus 20 plus 15 times 1 upon x square minus 6 into 1 upon x raised to 4 plus 1 upon x to the power 6. You can check here, plus minus plus minus plus minus plus. Okay, in this way expansion of 6th power of sin theta, and similar to 6th power of cos theta, here also we have to collect first term and last term, second last, third and third last. So this is equal to minus 1 upon 64 into bracket x to the power 6 plus 1 upon x to the power 6 minus 6 times x raised to 4, minus sign is taken common, plus 1 upon x raised to 4 plus 15 times x square plus 1 upon x square minus 20. Okay. Now x raised to n plus 1 upon x raised to n. Again same formula. X raised to n plus 1 upon x raised to n, that will be 2 cos n theta. Applying that formula, minus 1 upon 64, 2 cos 6 theta, minus 6 into 2 cos 4 theta, plus 15 into 2 cos 2 theta, minus 20. Take 2 common. So this is equal to minus 1 upon 32 cos 6 theta minus 6 cos 4 theta plus 15 cos 2 theta minus 10. Step number 2 is over. Now what we have to do? Now let us move towards our problem. That is this one. We have to prove 6th power of cos theta minus 6th power of sin theta is equal to this one. So 6th power of cos theta is what? This one. 6th power of cos theta is this, 1 upon 32 6 cos 6 theta plus 6 cos 4 theta plus 15 cos 2 theta plus 10. And 6th power of sin theta is minus 1 upon 32, this bracket. So we have to subtract these terms from these terms. So taking 1 upon 32 common from, you can say this is equation 1, this is equation 2. 1 minus 2, that gives, taking 1 upon 32 common, into bracket remains, minus, we have to subtract this from this, so minus minus plus. So we have to take addition just, because minus minus this becomes plus. cos 6 theta plus cos 6 theta, that is 2 cos 6 theta. Then plus 6 cos 4 theta minus 6 cos 4 theta gets cancelled. 15 cos 2 theta plus 15 cos 2 theta, that is 30 cos 2 theta, plus 10 minus 10 gets cancelled. So you can take 2 common. Taking 2 common, this becomes 1 upon 16. Sorry, here, yes, our statement is LHS is equal to, we can write here, LHS is equal to this one. And then taking 2 common, 1 upon 16 into bracket cos 6 theta plus 15 cos 2 theta. This is right hand side, means statement is proved. In this way we have solved first sum. Now we have to solve sum number 2. This one you can see. Example number 2. If fourth power of sin theta into cos cube theta is equal to a cos theta plus b cos 3 theta plus c cos 5 theta plus d cos 7 theta, then find the values of a, b, c and d. Okay, let us find values of a, b, c, d. So before that we have to take LHS. Direct you can take LHS. LHS is equal to fourth power of sin theta into cos cube theta. Okay, fourth power of sin theta into cos cube theta. Now this is equal to fourth power of sin theta, that is nothing but 1 upon 2i x minus 1 upon x to the power 4 into cos cube theta, that is 1 upon 2 x plus 1 upon x cube. Okay, and then 1 upon 2i to the power 4, 1 upon 2 to the power 4, then I to the power 4, and this 1 upon 2 to the power 3 into 1 upon 2 to the power 3, and then remaining this bracket x minus 1 upon x to the power 4, x plus 1 upon x to the power 3. Again this is equal to 1 upon 2 to the power 4, that is 16, and 2 cube is 8. Then this becomes, or you can simply write 2 to the power 7 and I to the power 4, that is equal to 1. I to the power 4 is 1. Then here x minus 1 upon x to the power 4 can be written as x minus 1 upon x into x minus 1 upon x cube. Okay, so we can write here x minus 1 upon x into x minus 1 upon x its power 3 into x plus 1 upon x its power 3. We can club these two. We can take its multiplication. Power is same, so we can write this as 1 upon 2 to the power 7 x minus 1 upon x into x minus 1 upon x into x plus 1 upon x cube of this, and you know a minus b into a plus b is equal to a square minus b square. You know that formula, a minus b into a plus b is equal to a square minus b square. Apply this formula. Then this can be written as 1 upon 2 to the power 7 x minus 1 upon x, and then x square minus 1 upon x square to the power 3. Again, you know, a minus b cube is equal to a minus b cube is equal to a cube minus 3 times a square b plus 3 times a b square minus b cube. You know this formula. Okay, apply this formula here to expand this bracket. First expand this and then multiply by this bracket. So this is equal to 1 upon 2 to the power 7 x minus 1 upon x into x square cube, that is x to the power 6, minus 3 times x square square, that is x raised to 4 into 1 upon x square, x raised to 4 into 1 upon x square, plus 3 times x square into 1 upon x to the power 4, then minus 1 upon x to the power 6. Okay, so this is equal to again 1 upon 2 to the power 7. Simplify this, x minus 1 upon x into bracket x to the power 6 minus 3 times x square plus 3 times 1 upon x square minus 1 upon x to the power 6. Take multiplication of this bracket with this bracket. Okay, let us multiply. Yes. So this is equal to 1 upon 2 to the power 7 1 upon 2 to the power 7 x into this bracket, x into x to the power 6, that is x raised to 7 minus 3 times x cube plus 3 times x upon x square, that is what, 1 upon x minus 1 upon x to the power 5. Okay, then multiply by minus 1 upon x to this bracket, minus 1 upon x into x raised to 6, that is minus x to the power 5, then plus 3x minus 3 into 1 upon x cube plus 1 upon x to the power 7. Okay, this is the expansion. Now what we have to do, we have to collect similar to previous step, that is collect real part, collect first term, last term, second last, third last, then fourth and this term. So this is equal to 1 upon 2 to the power 7, 1 upon 2 to the power 7, x to the power 7 plus 1 upon x to the power 7 minus 3 times x cube and this one x cube plus 1 upon x cube plus 3 times x, where is x, here, 3x and plus 3 upon x, x plus 1 upon x, then fourth, this one and this one, minus x raised to 5 plus 1 upon x to the power 5. Again, you know, x to the power n plus 1 upon x to the power n, that is equal to 2 cos n theta. So this can be written as 1 upon 2 to the power 7, 2 cos 7 theta minus 3 times 2 cos, for this bracket, 2 cos 3 theta plus 3 times 2 cos theta minus, for this, 2 cos 5 theta. Okay. Now you can take 2 common throughout. So this is equal to 1 upon 2 to the power 6 into bracket cos 7 theta minus 3 cos 3 theta plus 3 cos theta minus cos 5 theta. Now this is equal to 1 upon 2 to the power 6. 2 to the power 6 is 64. So this can be written as 1 upon 64 cos 7 theta minus 3 upon 64 cos 3 theta plus 3 upon 64 cos theta minus 1 upon 64 cos 5 theta. Okay, let us arrange these terms. First of all, we want cos theta. 3 upon 64 cos theta. Okay, then we want cos 3 theta minus 3 upon 64 cos 3 theta. Then we want cos 5 theta minus 1 upon 64 cos 5 theta, and then last term, that is plus 1 upon 64 cos 7 theta. Okay, now we can write this in this form: a cos theta plus b cos 3 theta plus c cos 5 theta plus d cos 7 theta. Comparing this and this, we can write the values of a, b, c, d. A is equal to, this implies a is equal to 3 upon 64, b is equal to minus 3 upon 64, okay, then c is equal to minus 1 upon 64 and d is equal to 1 upon 64. Okay, these are values of a, b, c, d. This is sum number 2. Let us solve next sum, that is sum number 3. Yes, sum number 3. Find tan 5 theta in terms of tan theta and show that 1 minus tan square pi by 10 plus 5 times 4th power of tan of pi by 10 is equal to 0. Okay, let us solve this sum. Solution for this. Before that, you know, cos n theta is equal to, you know that formula, cos n theta is real part of nth power of cos theta plus I sin theta, and sin n theta is imaginary part of expansion of cos theta plus I sin theta to the power n. Okay, now here we want tan 5 theta. Solution for this: tan 5 theta is equal to sin of 5 theta upon cos 5 theta. Okay, this is tan 5 theta. Sin 5 theta is what? This is imaginary part of expansion of cos theta plus I sin theta to the power 5, and cos 5 theta is a real part of expansion of cos theta plus I sin theta to the power 5. We have to expand this bracket till the power 5 by using binomial expansion, and then its real part will be cos 5 theta and its imaginary part will be sin 5 theta. Only we have to expand this bracket. So this is equal to we are going to expand cos theta plus I sin theta to the power 5. In between these two terms there is plus sign and power is also positive. So in the expansion all terms will be positive, and n is 5 means what will be binomial coefficients? N is equal to 5. Then binomial coefficients will be 1, 5, 10, 10, 5, 1. Okay. So this is equal to fifth power of cos theta. Okay. Then plus 5 times fourth power of cos theta into I sin theta plus 10 times cos cube theta into I sin theta its square. Next term 1, 5, 10, 10, 5, 1 plus 10 times cos square theta, 10 times cos square theta into I sin theta to the power 3. Okay. Then plus 5 cos theta into I sin theta to the power 4 plus I sin theta to the power 5. You know, I here I square is minus 1, I cube minus I raised to 4, 1, I raised to 5, I. So we can write this as, this is equal to fifth power of cos theta plus I into 5 times fourth power of cos theta into sin theta. I square means minus 1 minus 10 times cos cube theta into sin square theta. I cube means minus I into 10 times cos square theta into sin cube theta plus 5 times I raised to 4 is 1 plus 5 times cos theta into fourth power of sin theta plus I to the power 5 is I plus I fifth power of sin theta. This is expansion of cos theta plus I sin theta to the power 5. Let us collect real part, first real part and then imaginary part. So this is equal to, real part is this one, where I is not there in that term. We are collecting a real part. Then this one. So real part is fifth power of cos theta minus 10 times cos cube theta into sin square theta plus 5 times cos theta into fourth power of sin theta. Okay, this is the real part. Then we are collecting imaginary part plus I into 5 times fourth power of cos theta into sin theta. Then this one minus 10 times cos square theta into sine cube theta plus fifth power of sine theta. Okay. In this way, real part is collected, imaginary part is also collected. And this is equal to, this is nothing but real part is this one. This is cos phi theta plus I into this is sin phi theta. Cos phi theta plus I into sin phi theta. Means cos phi theta is real part and sin phi theta is imaginary part. Now we have to find out tan phi theta. First, let us find tan phi theta first. Hence, tan phi theta is equal to, tan phi theta is sin phi theta upon cos phi theta. Sin phi theta is imaginary part of this. Imaginary part. So, 5 times fourth power of cos theta into sin theta minus 10 times cos square theta into sin cube theta plus fifth power of sin theta all divided by cos phi theta. And cos phi theta is real part. Fifth power of cos theta, then minus 10 times cos cube theta into sin square theta, okay, plus 5 times cos theta into fourth power of sin theta. Now what we have to do? Divide numerator and denominator by highest power of cosine function. Here highest power of cosine function is fifth power of cos theta. Divide numerator and denominator by fifth power of cos theta. So we can write here, divide numerator and denominator by fifth power of cos theta. Then what will happen? Just eliminate cosine functions from each term, and whatever may be sine function, you replace that sine function by tangent function. Okay, then answer will be, this is equal to 5 times, in this term this is eliminated, sine theta, replace this by tan theta, this is tan theta minus 10 times this cos square theta is eliminated, sine cube theta, replacing this by tan cube theta plus fifth power of tan theta, and whole divided by fifth power of cos theta upon fifth power of cos theta, that is equal to 1 minus 10 times, this can be written as tan square theta plus 5 times fourth power of tan theta. Okay, and this is expansion of tan phi theta. Okay, now we have to prove this one, 1 minus tan square pi by 10, this we have to prove. So theta is pi by 10, so put theta is equal to pi by 10 here. Before that, this is tan phi theta, taking reciprocal on both sides, 1 upon tan phi theta, that becomes 1 upon tan phi theta, that becomes cot phi theta. Cot phi theta is equal to, now here denominator becomes numerator and numerator becomes denominator. So 1 minus 10 times tan square theta plus 5 times fourth power of tan theta divided by 5 times tan theta minus 10 times tan cube theta plus fifth power of tan theta. Put theta is equal to pi by 10. put theta is equal to pi by 10. Then left hand side, cot of 5 times pi by 10, that becomes cot pi by 2. This becomes cot pi by 2. Okay, and you know cot pi by 2 is equal to what? Cot pi by 2 is equal to 0, because cot pi by 2 is reciprocal of tan pi by 2, and you know tan pi by 2 is infinite, but cot pi by 2 reciprocal of infinite, that is 1 upon that is 0. Okay, so cot pi by 2 is 0. If we replace if we put here and all theta replacing by pi by 10, 0 is equal to 1 minus 10 times tan square pi by 10 plus 5 times 4th power of tan of pi by 10 divided by 5 times tan pi by 10 minus 10 times tan cube pi by 10 plus 5th power of tan of pi by 10. Okay, now left hand side is 0, so right hand side must be 0, and right hand side will be 0 only when numerator becomes 0. This must be 0. Okay, so we can write numerator 1 minus 10 times tan square pi by 10 plus 5 times 4th power of tan of pi by 10. This must be equal to 0. Then only left hand side you will get. Okay, left hand side is 0 means right hand side must be 0, and right hand side 0 we will get only when numerator becomes 0. In this way this sum is also solved, and here we have proved the statement 1 minus this one 1 minus tan square pi by 10 plus 5 times 4th power of tan of pi by 10 is equal to 0. Sum number 3 is also solved. Let us solve sum number 4. Yes, this one. Sum number 4. Here, prove that sin 6 theta upon sin 2 theta is equal to this one. Here, we have to take LHS and try to get RHS. So, solution for this. You know, sin 2 theta is equal to what? Sin 2 theta is equal to 2 sin theta cos theta. 2 sin theta cos theta. We have to find out sin 6 theta. Sin 6 theta is nothing but imaginary part of cos theta plus I sin theta to the power 6. We have to expand this. In between these two terms there is plus sign. Power is also positive. So all terms must be, in the expansion all terms must be positive. And here n is 6 means binomial coefficients will be n is equal to 6 because of this. N is equal to 6. Binomial coefficients will be 1, 6, 15, 20, 15, 6, 1. These are binomial coefficients. Okay. So considering these binomial coefficients, we have to expand this one. So sin 6 theta is equal to imaginary part, or yes, imaginary part of expansion of this. Expansion will be 6th power of cos theta plus 6 times 5th power of cos theta into I sin theta. Power of second term increases, power of second factor increases, and power of first factor decreases by 1. So plus 15 times 4th power of cos theta into I sin theta to the power 4 plus 20 cos cube theta into I sin theta to the power 3 plus 15 times cos square theta into I sin theta to the power 4 plus 6 times cos theta into I sin theta to the power 5 and last term I sin theta to the power 6. Considering values of I to the power n, you know I square is minus 1, I cube is minus I to the power 4 is 1. Means 1 I minus 1 minus I. 1 I minus 1 minus I. Same values repeats. So this is equal to imaginary part of, now simplify this, sixth power of cos theta, then plus I 6 into fifth power of cos theta into sin theta. Sorry, here 15 times fourth power of cos theta into, this will be square, not fourth power, square. Yes, I square means minus 1 minus 15 times fourth power of cos theta into sin square theta plus this term I cube, that is minus I into 20 times cos cube theta into sin cube theta. Then I raised to 4 is 1 plus 15 times cos square theta into fourth power of sin theta plus I to the power 5 is I 6 times cos theta into fifth power of sin theta, and last term I to the power 6, that is I square is equal to minus 1 minus 6th power of sin theta. This is expansion of cos theta plus I sin theta to the power 6. Okay, let us collect a real part, but we want sin 6 theta only. So can I write imaginary part only? So sin 6 theta, imaginary part, second term, that is 6 times fifth power of cos theta into sin theta. Then this term minus 20 times cos cube theta into sin cube theta. Then this term plus 6 times cos theta into fifth power of sin theta. This is sin 6 theta and this is sin 2 theta. Sin 2 theta and this is sin 6 theta. Let us take LHS now. Hence LHS is equal to, what is LHS? Sin 6 theta divided by sin 2 theta. But this is sin 6 theta. This is what? Sin 6 theta. Divide each term of sin 6 theta by 2 sin theta cos theta, by this 2 sin theta cos theta. So this is equal to 6 times fifth power of cos theta into sin theta divided by 2 sin theta into cos theta minus 20 times cos cube theta into sin cube theta divided by 2 sin theta cos theta plus 6 times cos theta into fifth power of sin theta divided by 2 times sin theta into cos theta. Okay, now simplify this. We want right hand side this one, 16 times fourth power of cos theta minus 16 times cos square theta plus 3. We want this. So expansion and simplification is required. So LHS becomes 3 times fourth power of cos theta minus 10 times cos square theta into sin square theta, cos square theta into sin square theta. Okay, plus 2 3 is 6, 3 times cos theta gets cancelled, fourth power of sin theta. Okay, but we want all terms in terms of cosine function. We have to replace this and this. So is equal to 3 times fourth power of cos theta, keep this term as it is, minus 10 times cos square theta into sin square theta. It can be written as, replace sin square theta by 1 minus cos square theta plus 3 times fourth power of sin theta, that is sin square theta, its square. Sin square theta is 1 minus cos square theta, square of this. Expand, this is equal to 3 times fourth power of cos theta minus this into this, minus 10 times cos square theta minus plus 10 times fourth power of cos theta plus 3. Expansion of this, a minus b square, that is a square minus 2 times 1 into this plus square of second term, that is fourth power of cos theta. Again taking multiplication, this is equal to 3 times fourth power of cos theta minus 10 times cos square theta plus 10 times fourth power of cos theta plus 3 into 1 3 minus 3 into 2 6 times cos square theta plus 3 times fourth power of cos theta. Okay, now we can collect this term and this term. That becomes, this is equal to 16 times fourth power of cos theta. Now you can collect this and this term. That becomes minus 16 times cos square theta. Okay, now remaining only one term, that is plus 3, and this is equal to RHS of the statement which we are going to prove. You can check here, this is right hand side, 16 times fourth power of cos theta minus 16 times cos square theta plus 3, which we have proved here. In this way we have solved this sum also. LHS is equal to RHS. Okay, let us stop here. Thank you all.